Okay, so now we're going to do another example of this stretchy, flippy, shifty thing that we were working on in class earlier. So we talked about this particular problem, which was f of x equals 3 over x minus 2 plus 1. So let's actually graph it. The first thing we want to do is we want to establish what the base function is. So if this is kind of funky, I'm going to copy this and paste it over here. So this is, I didn't want to mess this up. But essentially what we're going to do is we're going to take the function that we have, and if you're kind of wondering how do we find the base function, what you're going to do is you're going to scratch out anything that doesn't have an x in it. So if I scratch out anything that doesn't have an x in it, pretty much I'm left with a something. I definitely have an x down there, and here I need some kind of a placeholder, so I'll just put 1. So this is how we find our base function. So step 0 is to get the base function, which in this case is y equals 1 over x. So if we go over here and we graph it, we remember that it's our one that has a little vertex-y thingy here at 1, 1, and a little vertex-y thingy here at -1, -1, and it goes something like this. Okay, so this is our base function, y equals 1 over x. So we're going to go back to our original list of things that we can do, and the first thing on this list is a horizontal shift. So this is something that happens inside the function, something that gets added to x inside the function itself. So we're going to see, okay, do we have that over here? We do. If you look right here, we have this little -2 thing. This is our horizontal shift. This is going to be 1. Okay, so I'm going to get us a new picture here. So before, what we had was y equals 1 over x. That was step 0. And step 1 is going to be to apply this horizontal shift here. So our next thing is going to be step 1, which is to take, that's my cat, which is to take y equals 1 over x minus 2. So see, we just took this little f minus 2 here because that was the very first step, is we want to do that horizontal shift. So we have x minus 2. Okay, so now what we're going to do is, since this is a -2, that means we're going to shift 2 units to the right. Yes, to the right. Okay, so we draw our little graph. I'm going to go ahead and draw what we had before. Remember, we had something here at 1, 1, and -1, -1, and went like that. All right, now we're going to shift. That's the worst area I've ever seen. Now we're going to shift 2 units to the right. So our new graph is going to look like this. So this point that was here at 1, 1 is actually going to go to over here. So it's not going to be 3, 1. And everything else is going to look the same. Over here we had -1, 1. Excuse me. We had -1, 1, and we'll go shift over 2 units to the right to 1, -1, and it'll look essentially the same. So we've done that very first step. Okay, so let's go back to our original equation. Actually, let's go back to our list of things that we can do. So we did our horizontal shift. Good. Now we need to do our horizontal compression or stretch. So what we're really asking is there any place inside our function where we're like multiplying some kind of a constant in front of that x? Okay, so we go and I look and I say, okay, there's my x, but there's nothing going on in front of it. Nothing's going on here, just my little 1 just hanging out. That's not exactly what I wanted that to look like. I lost my function. Okay, x minus 2. All right, But since nothing is being multiplied by that x right there, that means that step 2, I do nothing. There is no step 2. Nothing is happening. Nothing's getting multiplied in front of that x, so I have nothing to worry about. So let's see, well, what was it going to tell me to do for step 3? Step 3 is to do a horizontal flip over the y-axis if the x has a minus sign in front of it. So does my x have a minus sign? No. Okay, so again, step 3, I'm going to do nothing. Okay, so I've taken care of this one, I've taken care of this one. Well, actually, I didn't have anything to do here. Now my vertical flip, is there a giant minus sign in front of the entire function? Is there a giant minus sign like right here? No, there's not. There's nothing there. So again, I'm going to come over here for do nothing. Okay, let's go back to our list of things and scroll down a little bit. All right, the next thing that it's looking for is a vertical compression or a stretch. So is there something that's happening to the whole function? And the answer is yes. This whole function here is getting multiplied by 3. So what we're looking at here is we're taking our function here, this y equals 1 over x minus 2, which is what we had before, and we're going to multiply the whole thing, again, a terrible arrow, we're going to multiply the whole thing by 3 to get us y equals 3 over x minus 2. Sorry about that. So 3 over x minus 2. So now what we're trying to do, again, is we're trying to reconstruct, where did it go? We're trying to reconstruct this thing right here, one step at a time. So our next step was to put that 3 there. Okay, so again, we've got this, we're going to just redraw our graph where it was 1, 2, 3, and we had something going on here at 3, 1, and 1, negative 1, and then we went, and all right, so now what that's going to, I need practice with this clearly. So now what's going to happen next is, since we've got this 3 right here, this means we're going to vertically, this is step, look at our steps. This is going to be our this is going to be our vertical compression or our stretch. So this is what we're doing right here, is number 5. So 5 is vertical stretch, where we multiply all the y's by 3. So we have our table of old points and new points. We've only got 2 that we care about really, so our old points are 3, 1, and 1, negative 1. So the x's stay the same, and our y's are multiplied by 3. So the new point is 1 times 3 is 3, and negative 1 times 3 is negative 3. So our new points become 3, 3, and 1, negative 3. And then go neom and neom. These neurons are actually stretched out. It's just kind of hard to tell because we're only paying attention to 2 points. But this just kind of gives you an idea. Again, we're only really looking for the general shape here.